Hi guys, welcome to another session of Science at Home. I hope you had a good holiday break and welcome back. So today we are going to revise a bit of what we looked at last term, and we're going to look at a bit more about erosion, and we are also going to talk a little bit about how to recognise a scientific question, or what we think should be in a scientific question. So first of all, last term. Last term we talked about the structure of soil and the types of things that make up soil. And we discussed that there was an organic layer on top, which is dark, and that's made up of living things. And we talked about there being a mineral layer underneath that, which is usually made up of minerals, which is from broken down rock. And that those two have layers, and sometimes they start to intermix a little bit like that. We also looked at how the soil composition can be affected by the three different rock types, and we talked a bit about fossils. Can you remember what the three different rock types are? Okay, can you remember the first one? It started with I. You just have a think for a minute. Can you remember the name of that rock? That's right. It's igneous. So that's the one that started with I, and that's the one that's volcanic. And that means it's formed from liquid magma cooling down and solidifying. And that's how igneous rocks are formed. An example of that would be on Mount Wellington. And that type of igneous rock is called dolerite. There's lots of different types of igneous rock, but dolerite is a very common one in Tasmania. And that's formed from cooling magma. And it cools underneath the earth when it gets close to the surface. Can you remember the second type of rock? Have a think for a second. Maybe write it down if you can think it. If you can think of it, and just take a second. That's right, it's sedimentary. And that's the rock that's made up of sediment. And rather than being formed from liquid magma cooling and forming a solid rock, sedimentary rocks are formed when sedimentary layers or sediment comes in and forms layers, and we call them sedimentary layers. And we have different types of sediment. We can have sand sediment, or we can have mud sediment, and mud's a bit finer than sand. And then we can also have something called silt, which is even finer than mud. So there's a few different types of sediment that can form, but they all make what we call sedimentary rocks. And they form layers. Do you remember what we find in sedimentary rocks that we don't find in any other types of rock? That's right, we sometimes find fossils, because occasionally when we have erosion occurring, an animal or a stick or some bones might get stuck in the sediments, and then they get stuck and they die, or they just settle in there, and then more sediment comes on top, and they make an imprint in the sediment that's formed there. Now over time, the sediment gets compacted and cemented together, which just means they stick together, and with a bit of pressure it settles down and forms a rock. But that structure that was in there, whether it was living, a stick or an animal or whatever, it's dead now, and it just leaves an imprint in the layers. And like hundreds and hundreds of years later, we might dig up that sedimentary rock and discover the imprint that was in there and go, oh wow, that animal must have been alive a long time ago. And we don't get fossils in igneous rocks, because igneous form from molten magma, which is really, really hot, like really super hot. But we do get it in sedimentary rocks, because sedimentary rocks are just formed from layers going on top of each other. And often it's because stuff's been eroded away or sediment has sprinkled out in the ocean or a lake and formed these layers. Now there is one more type of rock which we really haven't talked about too much, and we're probably not going to talk about it too much today either. I only mentioned it once or twice. Can you remember what that rock's called? It starts with M. Maybe think and try and write it down. That's right. It's metamorphic. It's metamorphic rock. And that's the type of rock, now usually it's a sedimentary rock, which has had extra heat and pressure put on it. And it's sort of often done underground. And it's pushed down underground, and that's put lots of pressure. So the sediments and the rock and sediments have actually almost started to melt, and they've cooked, like when you put a cake in an oven. You know how when you put the cake, before the cake goes in the oven, it's kind of a bit mudgy, and it sometimes has layers and things. When you put it in the oven, it cooks in the oven for a while, and then and when you take it out of the oven, it's different. It's still the same ingredients, but it looks different. It's a cake, it's been cooked. Same a bit with metamorphic rocks. You have some rock, probably sedimentary rock, and it's pushed deep under the earth by some big forces, which we'll talk about later on. And the pressure and the heat under the earth cooks it. And so metamorphic rocks, they've changed, they've metamorphosed. So they are different. Now, we've got these three types of rocks. Now, how these types of rocks interrelate with soil is how the rocks get broken down and how living things kind of get added in. So as rocks break down, they form minerals, and that forms a mineral layer. And as organic things break down, they form organic matter, and that makes the organic layer. Now what can happen, and what does happen, it happens now, important point, it happens naturally. And humans can do things to make it happen faster. And what is it? It is erosion. That's what I'm talking about. So erosion happens naturally. Things will naturally erode, and that is good. It is all part of the rock cycle. It is all part of how the world works. Erosion happens and is a good part of a natural, healthy ecosystem. However, there are things that humans can do that will accelerate erosion or make it happen too much. Now, those things, we do a bunch of different things. Now, before we talk about those, we're going to briefly look at a few points that are how natural erosion occurs. So, natural erosion is really how you've got soil, and we're usually talking about soil when we're talking about erosion. And we have things come in which move the soil away. Now, that can happen by wind blowing, and you've seen it, like how wind can blow soil away, or water can wash it away. Now, they're our two main ones. There's lots of other things that sort of can exacerbate erosion or make erosion worse, and we're gonna talk about those. But our two main things that actually do the erosion is wind and water, and the different forms that they come in. So, how does it do it? Like wind can just just blows it away. Water can come in the forms of a river that sort of washes it away, or waves that crash against rock and cliffs. So lots of power, and they just slowly bash away at it. Now, the important thing about water, and really about wind in terms of erosion, is that the faster the water moves, the more it can carry. Say that again. The faster the water moves, the more it can carry, and usually the more force it has behind it. Now, can you think of a time when water has moved really fast? When does that usually occur? When do you see lots of water running along the road? Can you think of a time? That's right, usually when there's a storm. So when you get lots of water, it tends to move really fast. And so during storms, we get a lot of erosion happening Because not only is the water moving really fast, there's a lot of it moving really fast, which makes the water carry more. There's just more of it happening. And the same for wind. Now, there's certain things that we do as humans that can make this process accelerate or become worse than it normally would. So when it happens normally, it's a good thing. Rocks and soil need to be eroded because they deposit it in other places where it needs to be. So it's actually a healthy process. But if we do things as people, we don't manage the land well, or we don't manage our environment well, it can get a lot worse. And things we do is, you imagine if the water moving fast makes erosion happen more, what would we need to do to make erosion happen less? We'd need to slow the water down. How are we going to slow the water down? How do you slow anything down? Usually you put something in front of it, don't you? So what we've got in a natural situation is that as water comes down from the sky, it hits trees and leaves and it slows down. First of all, as it falls from the sky, it slows down. Then when it hits the ground, it also slows down because there's bushes and twigs on the ground and leaves on the ground. And what those bushes and leaves do, they also slow it down. So when it comes through the trees and hits the bushes and hits the leaves that are on the ground, it then sort of moves slowly and has time to soak into the ground. So not a lot of erosion occurs. A little bit does, but not a lot.